thank you, everyone. I'm going to try and keep an eye on Discord as we go through. So if you were between the couple of tracks ago, Bo Bullock was on and he was talking about a class he was doing and trying to not have a bunch of downtime for the workshop and really just doing more of like slides and teaching back and forth with the actual workshop content and working through demos. So that's what we're going to do. The one disclaimer I'll say up front is the webcam on the computer I was going to use decided it didn't want to work at 11 o'clock this morning. And so I switched over to a new computer. So if we see any issues, we'll see how that goes. We'll just roll with it. We'll do it live. Okay, so this is an intro to Git for security professionals, which really it's just an intro to Git given at Wild West Hackin Fest. So I actually have been doing kind of a mix of software and development things for about the last 10 years. I started primarily as a software developer after I came out of grad school doing more computer architecture research, mostly doing Python, although originally it was more C and C++ and some GPU programming back once upon a time, and then doing some system administration. So it got me, on the command line, working in Linux, working with some web apps. And then in about 2016, I made a shift over to cybersecurity. And so I came at cybersecurity from the software developer / open source evangelist perspective. And so I've kind of built myself a little role doing cyber assessment, basically red teaming on supercomputers at my day job. Typically, you can find me as Ian Lee 1521 all over the place. So Twitter, GitHub, SpeakerDeck. If you go to that speakerdeck.com site, I know Deb already posted the slides, but you can also find the slides there and links to other slides and other talks I've given, including the Hackfest talk that Jason mentioned. And coming from a software developer background, coming from a background of open source development, I have been really influenced and really strongly latched onto this idea of leaving things better than you found them. And what that means to me, and we'll get into it a little more as the workshop goes on, is it doesn't take a massive amount of effort for you to make a difference in a project, in an organization. You can do a lot with a very minimal investment. And for me, this applies to software development, it applies to open source development, and also applies to security tools. As I'm going through reading some documentation about some new tool that I'm just learning about, a lot of times those tools are on GitHub. And if I find some typo, some minor fix, some little something, I can give back. And that's actually one of the things that's really drawn me and kept me with open source for as long as it has. And so that's the mindset that I want to try and get you all to sort of buy in on. That's what I'm trying to sell here in this workshop. And so the first half of the workshop is going to be roughly covering the Git basics. I'll say more about this later, but effectively, I would argue that anything that's code or a script or anything like that you're ever doing, put it in Git. Even if you have no intention to ever share it with anyone ever, if you put it in Git, even on your local computer, then you have a copy. You have something you can roll back to, and you can just get more and more familiar with the tools. So the first half will roughly focus on the basics, and then the second half will actually get going to do some real stuff. So what I did last night is I went around some of the talks that I'd heard during the conference and tried to go find some tools and come up with some ideas, just little simple snippet ideas of like, how would I contribute to this tool? And so we'll actually go through some of those examples. And so I'll be switching back and forth from the slides and the terminal as well. I did post a link in the Discord, but the only thing you really need to make full use of this workshop is going to be a working version of Git. So if you have a terminal available and you can run git version, git -- version, and it's any sort of a number, you get any sort of response like that, then you're good to go. That's all you should need. I happen to be using a Windows computer, using WSL, the Windows subsystem for Linux right now. And so I'm using effectively an Ubuntu 20.04 Linux operating system as this terminal. So that's just where I'm coming from. So what is version control? If you're not familiar with the term ever, you might have heard of it. Basically, once upon a time, you didn't have version control. You had a bunch of files and you would version them with names. And when you lost something, then it was gone. If you didn't have the undo button available at the time, it was sometimes difficult to get back to what you were working on or the version you had yesterday, especially if you changed something and then it broke more along the lines. And so, another way to look at that, right? So two different comics here, looking at multiple different versions of like, how are you going to name this this spreadsheet, and which one's the current one, and which one's actually the one that has the right content in it. With Git, it allows you to keep track of your files, make changes to them, having the same name, right? Your myscript.py, and make changes to it, check them in, give comments, give some history and some context for why things are happening the way they're happening. This is useful for you if you've started any sort of script, then I would consider you a developer at that point. You're doing something to develop your own scripting, your own code, your own documentation files, whatever that is. And there was a saying I heard once upon a time that was something like, the you from 6 months ago is the same as a stranger looking at the code you write today. So having this history, having the ability to go back in time and see what's going on is really powerful. And yeah, I see there's a comment that it forces good behavior, and we'll get into some of the behaviors that are both good and bad as we go. So there's a number of different version control tools out there. There's Git, which is what I'm going to be talking about, mostly because that's the 800-pound gorilla in the room right now. Others you might have heard of are Subversion, Perforce, and Mercurial. So these are a combination. Subversion's a centralized version control system. The idea is there's one server in one place, and that is the copy of record for a piece of code, and you check things out of it, and you check things back into it. So when you make changes, you're talking to this one server. Git and Mercurial in particular are two that are still sort of alive and kicking. Git's the main one in use. And with those, they're distributed version control systems. So the idea is there's a copy on a server. In the case of Git, maybe it's on GitHub or GitLab, and there's a copy there, but I have a full copy of all the code locally as well. And so when I make changes, it's only being made to my local copy, and I could push those changes to that server, or I could push them to another server. So it gives you the ability to know what's going on. And this is kind of how communities have formed nowadays, is you'll have one repository with one set of code, and then other people will take that and they'll fork it. So they'll take the full copy of the code, and then they'll go off in a different direction. And open source really gives the ability to do that. So what I will say, and what I hope to dispel as we go through this workshop, is that Git can seem kind of scary to a lot of people. It's this thing. There's a lot of commands. It can be complicated to understand. How do I know what to do? How will I fix things? And what I'll say is, Git has gotten a lot easier to keep up with. So particularly any Git version greater than 2. In particular, although they started doing this a lot with like 1.8, which is what you have on CentOS or RHEL 7 systems still, is the Git commands that you run will really try and point you to the next commands you might be interested in running. And so as we go through some of the demos, you'll see a lot more of those examples, and I'll try and point them out as we go. So I want to talk just very briefly about configuration. And there's a couple of things that you'll want to do. The first two, I'm putting them as required because Git will actually complain to you if you don't do this. So git config -- global user.name, you're setting your name, and then user.email, your email address, for what Git will associate in the metadata for a commit. And so as we go through the examples, we'll see more about how this works. But basically, when you make a change, you put the metadata into that change that says, Ian Lee, with the email address ianlee1521@gmail.com, made this change, changed these lines of files at this particular time on this particular date, and that was based on this previous version of the code at this other commit. And so that's fairly strongly required. And there's many more config options that you can get into. A couple of the other optional ones, some of these might be on by default, depending on what Git version you're in, are color.ui. So that'll colorize the output with sort of a green-red for changes of additions and deletions from when you're doing your comparisons. The credential helper, if you're using HTTPS connections for your Git interactions, then it'll allow you to cache your username and password, so you don't have to keep typing that every single time you interact with another Git server. And the push.default is a change that they made in Git 1.8, I think is when that became available, and 2.0 it became the standard. And so this is just a way to adopt this. This is the default behavior if you're in Git version 2 or above, but you can sort of explicitly select it if you want. And then for this course, one of the things that can trip you up a little bit in some tools is it'll use the default pager for your terminal. And a lot of times this will be something like less or more. And so you'll have to spacebar through the changes if you're looking at a bunch of changes at once. And so if you set your pager in Git to cat, then it will use the cat tool to actually get all the output of the screen all at once. And that can be useful in some cases. So I just wanted to also say about branch names. So there's been quite a bit of a shift recently in the software development community. This year is when it really got going for a variety of reasons. And there's been a shift from conventionally and historically, the default branch of a Git repository is the master branch. And this is meant to refer to sort of the master copy of something. And for a number of reasons, there's been a shift away from master and over to using main as the default branch name in a couple of different communities. So github.com is switching to use this as their default. GitLab has already made the switch. And I believe Git, the actual tool, is switching over to use that as their default branch name in the fullness of time. Not everyone agrees. I'm not really here to argue. All I really want to say is you might find one or the other branch name as the default. Now, what I'll also say is that that's the default branch name. And the reality is that most of the code hosting tools, GitLab.com, GitHub.com, they all allow you to pick which branch in a repository is the actual default branch. And so another convention you'll see a lot is to have a dev branch, where you might have the dev branch is where all your local work happens, and then you have a different branch, which is the master branch, where your actual sort of releases happen. And we'll get into this a bit more towards the end of the first half of the workshop. So let's just get started. Again, the slides are mainly here, so if you want to follow along, jump back and forth to see what the commands are and how they work. And what we'll actually do is we'll end up going through this as a live demo, and we'll just kind of go through things. But starting off, the first thing you'd want to do is init a new repo. So what I'm going to assume is that you're working on some new thing. You have no other code hosting tool you're relying on. You're not starting working on some other project. You're just starting like, I have a script. I have this awesome script idea, and I want to get that thing into version control. So as I change it going forward. So if you put the GoToWebinar off to the side here and have a terminal open with just your command prompt, you can see I'm on Git version 225.1. So this will change what you see for the help text a little bit, but shouldn't be that different. So if you run git init and then the name of a directory, so I'm just going to say intro to Git for the directory that I want to start. And what that'll do is it'll tell me it's initializing an empty Git repository in my current directory in the intro to Git. So if I do an ls to list the files, I'll see that I have that directory there. And if I change into that directory, then depending on which operating system you're on, depending on how your shell's configured, you may or may not have some of the help information. But one of the interesting things you'll see, and one of the things that can be a lot of help, is to have your prompt help you out with what version control tool you're using and what branch you're on. And there'll be other little markers that may show up as we go. So this is all stock Ubuntu 2004. I haven't configured anything more from there. So since I just made this directory, it's an empty directory. If I list all the files in the directory, you can see there's the .git directory, and that's where all the metadata and where Git keeps sort of all its internal stuff is. So for the most part, we're going to ignore that file. But just to take a quick look in it, if you do, you'll see there's a couple of files, like a head file and then a config and a description file. The only one you really may end up playing a lot around with is the config file. And so when you run things like git config, if you don't use the -- global flag, then it will do it only in the scope of the current repository you're in. With the global, it does it at your user profile level. And so if you want to make a change in one repository that's different from your sort of user default, that's how you can configure it, and that's where you would see it. And so if we just look in that file, you'll see a sort of an ini style output there. And this will grow as other Git commands interact with this repo. Okay. So we have an empty file. There's a number of different ways that you could interact with this, right? If you're more Linux savvy, come from a system administration background, Vim might be your tool, or Emacs might be your tool, or Nano might be your tool. Whichever editor you want to use doesn't really make a whole lot of difference. And so for the moment, I'm just going to start with Vim to start a new file. So I'm just going to start, like a lot of good projects, with a good README file. And so here I'm going to name it, largely by convention, capital readme.md. So readme.markdown file. And if I hit enter, then I can start putting some text into this file. So I'm going to say intro to Git, starting with this hash here. And in Markdown, this single hash with a space after it denotes a heading 1 marker. And so we'll see why that's relevant later. And you can also see that Vim is doing some syntax highlighting because it knows that this is a Markdown file and it knows what the syntax means. So if I add some text here, so welcome to the workshop, and then maybe I would want to add a second heading. So a heading 2 is with 2 hashes, and maybe I'll say contact the instructor, and we'll say Ian can be found at https://ian1521. So we'll do something like that. We'll make some change to the file. For you, it can be whatever you want, whatever changes you want. For this workshop, I'm really going to be fairly agnostic to what the actual changes, what the file contents are, because that's going to vary so much across different projects. So once we've edited the file, we can quit out of it. If you're using Vim, it's :WQ. And you'll see one of the things that's changed on my prompt here is I get this X here. And so this X is the sort of visual marker that something in my Git repo has changed. You may or may not have this, and there's a lot of variation in how to configure this. So I won't go into a lot of detail about it, but this is, again, just stock Ubuntu 2004 Windows WSL. So if you're using the same, you'll probably see the same. And so if I list out the files, I see my readme.txt. And now I want to introduce the next sort of most important command here, which is going to be git status. And I'm actually just going to mostly stay in the terminal, I think, rather than switching too much back and forth. So git status is going to be the next command that we'll talk about. And it gives you a lot of information right off the bat. It'll tell you what branch you're on. And again, this will vary slightly by Git versions, but this has been fairly stable for most of 2. anything. It'll tell me there's no commits yet, which makes sense because it's a brand new repository. And it'll tell me there are some untracked files. So this is a file that Git doesn't yet know anything about. It's just telling me, hey, I have this file, readme.md, and if I wanted to, you could use git add the file name to include it in what will be committed. Use git add to track. So let's go ahead and do that. Let's git add readme.md and git status. And you'll see me do git status all the time. That's kind of like muscle memory has just told me, that's the command you run all the time to see what's going on. And so here we'll see I'm still on the master branch. There's still no commits yet, but there's a change that's ready to be committed. So I'm going to add a new file, readme.md. Now, if I wanted to roll back in time, I could git rm -- cached that file. So I could git rm cached the file name. And if I do my git status again, you can see it's gone back to being in this untracked state. And I have a slide, we'll talk through the staging a little bit more in a second, but I think a lot of the examples will help and make a bit of sense. So git status, I see that it's untracked because we just unstaged it. We'll git add that file. Git status again will tell me that, oh, this change is going to be committed. There's a new file, readme.md. So let's go ahead and do that. So git commit -m. So I'm going to actually take these changes that I've staged and I want to make a new commit out of them. So -m is for the adding a message. And a lot of times for the first commit, you'll just see a commit message of initial commit. So I'm just going to stick to that for right now. And when I do that, I get some output. So it'll tell me master is the branch that I'm on. It's telling me that it's the root commit. So this is telling me I believe this would be saying the parent commit. So this is a child commit of the repository. And then this is the actual hash. So what it does is it takes the actual change you've committed along with the metadata about who you are, and it creates a SHA-1 hash of it. And so this is the first 7 characters of that. You can see there's the commit message that I had put. It's telling me that 1 file changed and 7 lines were inserted. So there were 7 insertions. And it was created with these file permissions for README. So now if I do an ls again, the file's there, and a git status will tell me that I'm on the master branch and there's nothing to commit. So I'm working, my working tree is clean. So nothing has changed in my local directory. Now, if I was to go back into this file, right, I've made my README, but I forgot a line. I wanted to do something else. So I can open up that file again, and I can say, references. All right, I want to add some references, and I'm going to add a link here to, let's say, blackhillsinfosec.com as a list. So I'll add that into my README, and now if I do a git status, it'll tell me a little bit more information, a little more context. So I can see I'm on the master branch still. I have some changes that are not staged for commit. And the change at the moment is that the readme.md file has been modified. And again, Git is really trying to be pretty helpful about what your next step is. So here it's kind of giving me 2 options. One would be use git add the file to update what will be committed. Or, so if I say, basically, I want to accept the changes I was just going to make. Or alternatively, git restore the file will discard the changes in the working directory. And it's also telling me that no changes have been added to the commit. Use git add or git commit with the -a flag. So one of the things we could have done before with git commit would have been to add the -a flag, and that'll include any files that have been changed or modified will be included in the commit, as long as Git is already tracking that file. So since we just have the one, we're just going to go ahead and add it. We'll just add it manually. So git add the README. Git status again, telling me that the changes are here to be committed. These are the changes that will be committed if I ran git commit. And it's telling me again, use git restore --stage the file name to unstage it. So if I said, you know what, well, I didn't actually want to make that change. Let me go back and redo that. So I'm going to go ahead and commit that. Added a references section. And so here it's telling me that it's the master. I'm still on the master branch, and here is the hash for the current commit that I'm on. There's the commit message telling me that 1 file was changed and there were 5 insertions. So I added 5 new lines to that file. If I do git status again, I'm back to my clean copy. Now let's say we want to add, going to move on a little bit, and so we're going to add a second file to the repository. So let's go ahead and we will edit, I don't know, hostname.py. So we're going to add a new Python script, and it's just going to spit out the host name of the system that I'm on. So we'll add a comment line at the top telling me which how to run it. So this is we'll say this is a Python 3 script, and we'll just say import, let's say socket, see if I can do this from memory. And then we'll say print socket dot get hostname, like so. Git status again will tell me, hey, there's a new file. This is an untracked file that Git doesn't know anything about yet. It's not keeping track of yet. And so if I was to try and run this file, test it out, you can see that it's actually running and it's spitting out the name of my computer, so Quasar, as the name of the computer. I could look at the contents of that file, and there it is. So now if I want to add that file into my repository, I can git add that file and commit it to the repository. So added a script for checking the hostname. Added a new file. You can see the hash changes again right there. Let's see. We've gone through status committing. Actually, I'm just going to go back to here. Git status commit. All right. So we've talked about, a lot of the introduction. And what I'll say is, if you're just working on your own code, you're just trying to keep track of something and you want to version it, like you would have some sort of versioning file rollback system for any Word document you would be working on. This is a lot of what you need. This will get you very far. So I can run a git status. I can see that I'm on a branch, and then every change that I've been making has been getting tracked by the system. Now, something to note, as we talk about conventions and as we start writing our comments, remember I said that after 6 months, you will not recognize your own code, no matter what it is that you wrote. And so putting in good commit messages is important. And so you can see that as time goes on, there can be kind of a tendency to fuddle the commit messages or the comments. So initially, I created a main loop and timing control, I enabled my config file parsing, bug fixes, I added some stuff, more code, does some code, my hands are typing words. So as time goes on, the commit messages can get a little less informative, and that's where having some discipline to keep your messages helpful will help yourself. And then as you start working on either other people's projects or just with interacting with other people in open source worlds, this will be a lot of the conventions and the norms that you'll end up encountering. Okay, so we've talked about, I have a thing and I'm going to kind of keep adding it and I'm going to keep growing that file. Well, how do I actually look at some of the details of the changes? So we already showed diff. So if I was to go in and edit this get hostname file, maybe here, maybe I don't want to just have this as a print. I want to be a little more Pythonic in my code. So we'll say if name equals main, then we're going to print the hostname. So basically, if this file is run as a script, then there we go. Then print this hostname. Otherwise, treat it more like a library and don't actually call this print function if I'm just importing this file. And this is a Git course, not a Python course, so I'm not going to go too deep into that. But if you do want to ask about that later, let me know. So again, git status will show me what's changed. There's that one file that's been modified. And now we can add in the git diff command. And what that'll do is that'll show me the file and how it's been changed. And here you can see I actually have not set up the pager, so it's actually showing this in probably either more or less. And you can see I could go up and down, but when I exit out of it, I lose that context. So just going to jump back to here, Git Config global for.pager. There we go. So now when I run git diff, it spits it all out to the terminal instead of using the pager like it was doing before. And then I can actually see it between commands. So here we can see this little minus sign here and then the 2 plus signs at the front of these two lines. So I've I've removed this line here, and I've added 2 new lines here. And you could decide, okay, yeah, that is the change I want to make, or no, I want to edit this further. For the sake of argument, we'll say, okay, we're happy with that change. So let's go ahead and commit that change as well. So now I'm going to use, instead of doing the explicit git add first, I'm just going to say, you know what, I have this one file. It's the only thing that's there, and I want to commit all the changes. So I'm going to say git commit -a. You can either do with a -a -m, or you can put the 2 of them together as -am. And then your quotes, and we'll say only print if run as a script. Okay, so now we've got our new commit. Now we get a little bit of a different output. We've got 1 file changed still, 2 additions, 1 deletion. And so that's telling me again what changed. And that's the cumulative across all the files. And you can see it gets a new hash. Now, one of the things to know is even if you make the same commit as the same person, but at a different time, you'll end up with a different hash. So the date and time that you create that commit, that you run that git commit command, is getting embedded into the metadata that gets hashed to come up with this hash. So this commit is unique theoretically across all time. In SHA-1, they're starting on some massive projects to run into hash collisions. And there's some work in the Git community to move to things like SHA-256 to try and get around that. But for most intents and purposes, you can say that this hash is unique to the commits anywhere in your repository. And okay, so now we've made some changes. But what if we want to see what are the changes we've made over time, right? It's like, all right, well, I know the change I just made, but what was the change I made yesterday? There's a couple of different commands you can do for that. Or even just, I made a command, I made a change, but what was that change? So there's 2 new commands I want to introduce. One is git show. So git show by itself with no arguments will just show the current commit. It'll show the data about that commit. So here we can see this is the full SHA-1 hash of that commit. Again, up here, we're only seeing the first 7 characters of it, but it's actually a full SHA-1 hash. You can see the author is me. That's what we configured with git configure before. We can see we're on the master branch. The date of that commit happened there. There's the commit message that I selected, and then here's the actual diff of what changed in that commit. So we're seeing that there's this file called hostname.py, and the minuses are before, the pluses are after, and that's what the 2 messages are down there. Okay, so that's showing me the current commit that I'm on. But what if I wanted to see, okay, well, this is the commit that I just did, but what are the commits, in the past? So there's a git log command, which will be a little tricky to run as time goes on, but shouldn't be too bad right now. Just barely, that's like I planned that. It fits just on one screen. So here we can see from the bottom, if you imagine this like a tree is the best way to think of Git. From the bottom is the root commit. So there was that first commit we made. There's the message initial commit. Here's a new commit that I made, or the second commit that I made where I added the references section. Here's the third commit where I added that script. And up here at the top, this is the current commit. And this is saying head is basically where you are at this present time. It's saying that I'm on the master branch and that this is where, this is the commit that I'm on here. This is showing without the details of what changed, but if you wanted to see what the changes were, you could do git show. And I see that there's a comment in the Discord about the character space for 7 characters isn't that large. And one of the things to know is that for fewer characters, you can end up with collisions. So for 7 characters on a really big repository, you may see some collisions. But just looking at these 4 commits, actually, I could use just the first character and Git is able to disambiguate which ones are which, because I've got 0, 7, A, and 3. So I could actually say git show 3. It doesn't show enough. All right, AA. Where are you going to cut off on me? Okay. So apparently there's a 4-character minimum. So with just 4 characters, Git can uniquely identify this commit, at least as of right now. In the future, this might change as there's a new commit that gets added where it uses the same first 4 characters. But for right now, I can say git show the first 4 characters, and it'll show me with including all the changes that I made in that commit. So if I do the git log again, I could pick, let's say, these 4 characters, git show, 7A8F, and there's that commit. So as things go on, you may end up needing more and more characters. The 7 is just the default, and that's a pretty good place to start for most use cases. You also could use, if you really wanted to, the full hash. So you could do git show like that. The other thing you can do, so this git log, a lot of the git commands, they work by reference. And so a reference could be the hash, but it also could be the branch name, or it could actually be something relative to something else. So you could say, for instance, so we were doing git show by the hash, so AFFC for that bottom one there. Or I could say git show master, which right now I only have the one branch, so it's just going to show the commit, the most recent commit on that branch, that master branch. Or I could say git show head, which head is pointing to the same place as master. So this is just saying I'm currently on the master branch. So these are synonyms for each other. And I'll talk a little more about that a bit later when we have some diagramming to go through. But the other thing you can do, although I don't do this that often, is you can do commits relative to other commits. So you can say relative to the master commit, go back 1 commit. So master 1 commit back, master is like that. And that's why in a lot of the command output, you'll see something like this, where you see the revision, or sorry, the word revision used rather than hash or branch, is because that revision could be a couple of different things. Okay, so here we're on our current branch. We've talked about how to add changes. We've talked about how to look at the changes. Just one other really helpful command that I want to talk about, and what I'll say is someone in the Discord yesterday, I think it was, had asked about, hey, well, what about Visual Studio Code? Could you show what Visual Studio Code looks like? Sorry, VS Code looks like for this. And so I do want to just probably switch over to that as the editor, just because I think it starts to show a couple of the more pieces a little bit more. And so this is VS Code. This is the main editor that I've been using for about a little over a year now. And before that, I was using Atom. Before that, I was using Sublime. Before that, I was using Vim. So Vim is, the old go-to for a lot of Linux sysadmin types because it's typically available on every system. So if you are a pen tester and you get access to a system, Vim is probably an editor that's available. VS Code, probably not. Again, this is a Git tutorial, not a VS Code tutorial, so I may gloss over a little bit there, but just a general orientation. Down at the bottom, there's a terminal that you can expand out here. So this is actually showing a terminal. VS Code has some plugins that allow you to connect to other sessions. So you can connect to a Windows subsystem for Linux distribution, or you can connect to a Docker container if you had one. Or there's also although apparently I don't have that one installed, there's a remote SSH plugin as well. And so you can use that to SSH and edit files on a remote system. But for right now, we're just editing inside of this WSL container. Okay, so if I do my ls and my git status, and you can see it's actually trying to help do some spell checking for me. All the commands here are going to work the same as they did over here on the terminal. As far as what shell prompt I'm using, this is the one that came just out of the box with the Ubuntu 2004 Windows subsystem for Linux distribution. So I haven't customized it at all. So there's my files. You can also see there's a file browser over here that VS Code is providing for me. And then if I was to open one of these, I get some syntax highlighting. And because this is VS Code is made by Microsoft, actually, it's an open source project by Microsoft. You can do a lot of customization, but it will do things. It can do things like actually sort of inline the what changed and when it changed, so you can see some details about it. I don't use that a lot, but it's kind of a nifty thing that's in there. The other thing it'll do is things like if I make changes, it'll show me the changes here. And let's see, so if I go ahead and I'm just going to add another import. So I'm going to import OS, for instance, and then I do my git status again. It's telling me that that file's modified. And this green here is telling me that that's the change that's being made. Okay. So jumping through these things a little bit. So I mentioned the terms, and I just want to stop and talk about them a little bit. And so there's a couple of terms that I've been using. So untracked, unmodified, modified, and staged are 4 terms that you'll find in Git trainings and Git documentation and so forth. And so here's sort of the flow chart of how things work. So if you have a file that's untracked, some new file you just created, Git knows nothing about it. Git isn't going to track it. If you do a git commit -a to include all the files, it's not actually going to grab that file. Instead, you have to explicitly git add the file if you want to add it into the stage, so that when you commit it, Git starts to know, hey, there's a file there and I need to be able to do things with that file. If there was a file that Git was tracking, right, it'd probably be in the unmodified state. That's what this is telling me here effectively. So I have two files, readme.md and hostname.py. Hostname is modified and readme.md is unmodified. So readme is here and hostname.py is here. So to move something from unmodified to modify it, obviously you edit the file. If I wanted to move it from modified to staged, then I could git add that file. So I could git add hostname.py, and now you can see it's moved to this changes to be committed. So this stage, that's why you see the word staged here showing up, because right now it's in this stage. So I've git added the file, and if I did the git commit, it would go back, it would create a new commit, and it would go back to being in this unmodified state. If I wanted to remove a file, I could git rm to remove, to take the file out of Git. And typically that also actually deletes the file. So just be a little careful with that. So, this is kind of what I was showing. 3 different versions here. We can see, state changes that would be committed. So this is what's the staged piece of the output. Changes that are not committed, or sorry, not staged for commit are in the modified state. And then things that are untracked are listed at the bottom. And again, Git's telling you what to do at each step to get those. So from there, I'm going to go back to the terminal just because there's a couple of different things we can do here. And I don't have all of these tools installed, so we'll see them mostly in the slides. But there's a couple of different commands you can do. So you can, to view your history. So we already talked about git log. That's just showing a linear history. I'm on a branch, show me all the commits going back as far as you can. There's a whole bunch of, oops, there we go. There are a whole bunch of options. So if you do git log -- help, you'll find all kinds of options that you can give git log. And so what I'm showing here, and for this workshop, is really going to be a fairly, it's an introduction. It's not the advanced course on all the different things you could do with Git. But you can limit things like the log size. You can tell it to give you the statistics. So there's a -- stat option that you can give it to get information about the changes. There's short stat. There's a whole pretty print option. You can say to turn coloring off or coloring on, and how you want to do that. There's all kinds of options. And so what I'd recommend is either looking at the git log, or really Git any command, right? I could say git status dash dash help, and it will give me a bunch of options I could throw at that as well. Either the git command dash dash help, or man for the manual page, git hyphen the command is the other way to get to the manual pages. Or you could just say man git, and then you would get the kind of top level piece here, which right here is showing me some of the other commands that are available and that I could run, get the manual pages for. Okay, so we've got our repository, and at this point we've got one modified file. If I do a git diff, nothing's actually changed. The reason for that is because I've actually already staged this file. If I, and git diff by default with no options is telling me only the things that are in a modified but not in the staged state. So there's a git diff dash dash staged will show me what changes are staged for commit. And why this is relevant is, let's say, I made the change to the hostname file there and I staged it, but then before I actually committed it, let's say I jumped over to the README here and I added I wanted to add another reference file here, another file. So now if I do my git status, I'll see that there's hostname.py has been staged, but the readme.md is only in that modified, not staged yet state. If I ran git commit -a, it would include all of this. The commit would include all of these changes. If I ran git commit without the -a, it would only take this change. So that's what the staging is doing or not. And why this is relevant is sometimes you want to change a bunch of files, but you only want to commit some small piece of that. So let's show that in a little more detail. So let's say git restore, we'll just unstage this file. So git restore staged hostname.py. Now if I do the git status, we'll see there's two files that are modified that haven't been staged. Again, git commit -a will include all of them, and Git's helpfully providing that for me right there. Now, when I was editing that host name, right, I added this import here, but maybe I wanted to add another line at the end here where I added another like print hello world. Let's say I made these two changes to this file. So if I do a git diff, I'll see all those changes. I see up here first that there's a readme.md file that I've changed down to there, and that's where I added the one line to it. Okay, that looks good. And hostname.py, you can see I added the import there and I added the print there. Now, git add by itself will add the entire file, but you actually don't have to stage all the changes in a file all at once. There's a couple of ways you can do this. The one that I really like the most is git add -p. So -p, what that'll do is it'll take you through interactively through all the changes in your directory where you're at, and it will give you some options for what you want to do with that change. So here it's telling me, okay, in the README file, I added this file. Do I want to stage this? Yes, no, quit. And then I actually don't even know what some of these are. There we go. Add this hunk and all later hunks in the file for A. Do not stage this hunk or any other hunks in this file. Or E to manually edit the hunk. So this is the hunk here is the change that it's showing at the given time. And here it's reprinting the command. And so let's just say, okay, well, I made that change, but I'm not quite ready to commit that yet. So I'm going to say, no, I don't want to commit that. And then, okay, here's this other file, hostname.py. And that's the one that had the two changes in it. And you can see there's another option that showed up. So if we use the question mark, we'll see the help text. And what Git's telling us is it can actually split the current hunk into smaller hunks. So this allows you to step through the changes to a file and only stage pieces of the file. So let's say, okay, I want to do this print hello world, but I added this import OS, but I'm really, I didn't actually make use of it yet. I don't actually want to commit that yet. So I can say S for split, And now it's split not the two changes, but just that first change. So import OS. Okay, well, that's the one, I'm not quite ready for that one yet. So we're going to say no, I'm not going to stage that one. But the second one with the print hello world, yeah, we're going to go ahead and stage that. So now if I do that git status again, we'll see that hostname.py, kind of a new view here, is modified, and it's been staged for commit, but it's also been modified and not staged for commit. And so this is saying that part of the file is staged and part of the file is not staged. So if I do my git diff -- staged, I can see, okay, that's the one line that I staged. That's the one that I wanted. And if I do a git diff without the staged, it'll show me the one piece that I left behind that I didn't actually stage for commit yet. And so I could come back and do that later, or I could commit the one thing and then come back and finish that code later. And the reason I'm doing this all from the command line as well is because while there's a number of different GUIs and there's a lot of integrations, I saw someone asked about integrating VS Code with GitHub. There's all kinds of options for that. And trying to track down all of them is fairly difficult. But if you understand the terminology here at the command line, all of the different GUIs you'll find pretty much all use the same terminology. So you'll see status, you'll see restore, you'll see add, you'll see branch, you'll see all the same terms. And so if we kind of start at the command line, it's much easier to transfer that to a GUI rather than trying to go the other way. Okay, so if I have that one change there, that one file, let's go ahead and commit just that print hello world, added print hello world. Okay, that's the part that we've changed. We do the git status again. The other two pieces that I hadn't modified remain unchanged. And if I do a git diff, I can see those two changes are right there. And let's see. So git add -p. Git add -p is the option for kind of walking through the changes and getting to pick interactively which ones you want to use. I think that's short for patch. Yeah, -- patch is the long verbose name for that. So git add. Okay. So there's some changes. If I went ahead and I git committed all of these changes, then we'd go back to a clean copy. So -a -m added a, let's see. The other thing you can do in the messages, just I didn't mention explicitly before, is you can have multi-line messages. So the convention that some Git services have is the first line of a Git commit message should be, I think it's less than or equal to 50 characters. And then you have a blank line, and then you can have longer lines of, I think it's 72 characters, is not a hard like technical limit, but more of a conventional limit. So if you do git commit -a, I could say new version, and then I could add the blank line here. And then I could say, okay, well, let's say I added another reference, and committed, imported OS for later use, like that. So there we go. So some of the Git messages will only show you the first line, but the whole message is there. So if I do a git show, there's the two changes, and there's my full Git message. Okay, now we're back at our Git status, and we're in a clean state. But yeah, so we're in a clean state there. The one other thing you could do is Git will actually track the files, but it'll also track the file permissions. So you can see right now, this file here is just a text file. So if I actually want to call this, I have to call it with Python3 hostname.py, and it will print out the messages. If I wanted to instead sort of do a /hostname.py, it won't work because it's not executable. So yeah, just press enter for a blank line, without the ending quote, so git commit stuff, and then just press enter, and then have your trailing quote at the end. So if I wanted to make something executable, I could chmod that to add the executable bit, and Git actually knows that I've changed that file. So here it's saying it's modified. It's a file that Git knows about, so it knows that it's modified. If I do an ls, I'll get the different coloring a lot of times, depending on your terminal settings. You can see the executable bit being set on it. And if you do a git diff, it's actually telling you how the mode has changed. So originally the file was 644 permissions, read write for user, read for group, read for others. And now I've added the executable bit to all three of those permission levels. Git status. And just to throw one other option at you. So again, we could do git commit or git add the file first and then commit it after that, or we could git commit with a -a. If there were multiple files, like let's say I also changed the README at the same time. Wild West Hackin best.com. Right, let's say I also changed that. Now I've got my two files. If I wanted to include the entire file, but not just a piece of a file, like we did with the -p, you can use the git commit -i flag, and that'll include a specific file. So I could say, okay, include the hostname.py file, and we'll use the message set executable bit. And that's changing that way. So again, that's the same as doing a git add hostname.py and then doing a git commit with that message. It's the same outcome at the end. And again, so if you wanted to know more about all the options, I recommend taking a look at the manual page. Actually, something I heard at a conference once that I'm not doing much of at the moment was, if you've got a version of Linux on your laptop, let's say, and you're on a long flight and you don't want to pay for the airplane Wi-Fi because it's expensive and your company's not going to reimburse it or whatever, start reading through some of the manual pages. Just pick your favorite tool and just say, okay, man, git, and then just start reading the documentation. This is all offline documentation. You could start learning and playing with the tools a bit. And you can get pretty far. You can learn about something new. Okay. So I still see, yes, because I made the change in the README file to add the Wild West Hackin Fest link. So let's just go ahead to clean that up. We'll say git commit added website to references. Yes, and now since this is COVID, no workshop would be complete without real life interruptions. You may hear my 1-year-old in the background who just got up from his nap. So I beg your forgiveness for that. All right. So now we were in git status. We just committed that last reference change, and see if our git status, the working tree is clean. So the working tree is just the current directory where I have a git repository. So git status. If I do that long listing again, remember I mentioned there was a git directory. All of the changes, all of the commits, all of the messages, any branches we make, they're all getting stored in the back in this one directory. This is a little different from in SVN. SVN actually, for every directory in Git, for every directory in the repository, you would get a .svn directory in every single directory. Instead, for Git, you just get one at the top level. And so this gives you actually a way to find Git repositories that might exist in the file system. So this will be the top directory of that repository. So if I made a new directory, right, if I make dir foo, I can cd into foo. There is no .git directory, but if I do a git status, I'm still in that same Git directory. So if I run git show, you'll see the last change that I made. Another thing that's interesting to note is you might have noticed that the little bit saying, hey, this repository has changed, hasn't shown up since I made the directory. And that's because Git only tracks files. It does not track directories. And so that executable bit won't show up until I go into the foo directory and I make a new file. Now it shows up and it's saying, this entire directory here isn't being tracked in by Git. So I could git add that directory. You can see there's a new file there. It's showing it with that path because I'm in that foo directory. If I go back up to the root of the repository, git status will show me the full path to that file. It's showing me the path relative to where I am in the tree at any given time. How do you, okay, so at this point I'm going to pause and take a look at Discord and see how we're doing on questions. We've also hit the halfway point, so we're actually going maybe a little bit slower than I was originally planning, but that should be fine. So how do you scrub the diff or show so someone can't see what you've changed? So this actually, I'm going to say that you can't. So the only way you can do that is to basically throw away the Git history entirely and recreate it. And so you really don't have a lot of ability to change that. Now, there are a couple of caveats to that. So one command that you can use is there's a git. So I'm here, I've staged this. Let me git commit. So I've staged this new file bar. Let's just say I put in some bad commit message and I was like, I didn't mean to actually put that commit message. There is a git commit -- amend flag that will allow you to change the commit message and recreate that commit. So let's say added bar.py. It's a better commit. And this seems to put me in nano, so let's see if I can figure out how to get out of here. There. Okay, so something to note. So up here, I get committed with this message, this repository, on the master branch, and it made the hash, or made a commit with this hash, ff597, blah, blah, blah. When I did the git commit amend and saved it, it created a new commit with the same change, but obviously at a different time now, and it has a new hash. So this is actually a different commit. So basically I've gone back in time and I've gone back in time and I've done a new commit instead of doing that other commit. Okay, so if I look at the LS and I look at the status, everything is clean again. Okay. So there's a question about what do you do if you've committed something that you really didn't want to commit? Canonical example is a password, right? You took a password and you checked it into Git. So I'm going to get to that with a demo shortly. So just to go through a couple of different commands here, we've got for viewing your history, we talked about git log. TIG is another command that you might see. It's just git spelled backwards, and this is a curses-based viewer for your Git history. And so you can kind of page through your files and see what's changed. Git K is a simple viewer. And I'm kind of skipping through this a little quickly because these are different tools you may or may not encounter, so we can get back to the questions that are coming up. So Git K is more of a GUI based. You can see the commits, you can see the progression of the commit history and how they change over time. And you can also see that I started doing Git tutorials and workshops back in at least 2016. Source tree is a nice option. I think of it as like a really shiny version of your history, but you can see how that history changes over time, and you can see how things start to branch and merge, which we haven't really talked about yet. And then actually, I added this yesterday, but there's a plugin called Git Graph for VS Code that you can get, or an extension, and it actually has a graphical GUI built in. So you can see the commits and the dates, the author, the commit hashes. If you were to click on one of these, you'd actually see the details of what changed in that thing. There's a whole bunch of other GUIs, but that's some of the ones that I want to hit on. Okay, so at this point, I'm going to start talking about branches. And the one thing that I want to say is that think of branches and by extension tags, which we won't cover as much, as sticky notes. So if you look at this over here, you can see there's 5 commits. Each of these lines, each of these dots represents a commit. And in this case, it's just a straight, I made a commit, then I made another commit, I made another change, another change, another change. And so as you go through that, you get this nice linear history. I have a master branch, and then I also made this new feature branch. But these are just sticky notes on a commit. All this is saying is master is a thing, and new feature is another thing, and each of those point to these 2 particular commits respectively. So master points to that commit, and new feature points to that yellow commit at the top. And so you can get pretty crazy with this, and you'll see different workflows as different open source communities will adopt different workflows for doing development. So this is Git Flow is one that you can go read a lot about. It's one of the more popular. It's also one of the more intense. And so you can get into workflows that look something like this, which I'm going to kind of gloss over, and then we'll go to a demo where we'll step through this a little more slowly. But you can see there's a couple of different colors here, colors representing different branches. So here I've got a master branch. This is what I was describing before, where you have different versions as your, you've got different commits that are your versions. These square boxes might actually be tags. Effectively, a branch is something that you move, so it advances in time as you make more commits, whereas a tag is kind of static. You make it pointing at one commit, and then really it should always point there going forward. And then you've got this other develop branch over here that may or may not interact with the repo. When you make features or new bug fixes, you might make a new branch and go off and do something and then merge it back or submit a pull request if you're in an open source community, or some software code hosting tool. Doesn't have to be open source. And so this would merge back into this commit, and then the history can continue together. And so you'll end up with histories that start branching and looking like this. You can add multiple features, you can merge things together and then tag them at particular versions. And then, maybe you go back at some point and go back to a previous version, make a new branch for a hotfix, and then you make a 0.1.1 release that's over here somewhere. So you can get pretty in depth with this. And like I said, there's a lot of articles on this Git flow methodology. And I think the biggest piece of it is just that master is where your sort of pristine code lives, and develop is where you're constantly changing things. Okay, so now I want to jump over to this visualizing Git website. And so this is a website anyone can go to. And let's see. We'll go with 200. Okay, so I'll take this link and stick it in Discord if you want to follow along. And the reason I like this is so when I teach Git tutorials, most of the time they're in person. And actually my favorite tool for doing Git tutorials is a whiteboard, because inevitably people have questions, actually like what's come up in Discord about, well, I did a change and I'm not sure if that's the change that I wanted to make, or how do I go back? How do I move things around? And pristine code only in Legends. Indeed. I don't believe I've ever found it myself, but it's the code that you send to your users, whether or not it's actually in working order or not. So what this visualization tool does, and this is just a D3 application, is it sort of throws away the parts of Git that are the actual changes. So it doesn't actually keep track of, like, I added this line to this file, which used to, before I found out about this, it was a lot harder to do these tutorials because you had to keep making changes to files and making up changes. So just to orient yourself, so here we've got an in-browser Git command thing. I think Git help does work. No, just help. There we go, just help by itself. I think actually I may have contributed this help back in a past life. We'll spit out some of the commands that you can do. So there's some, not all the Git commands are available, but a fair number of them. And so we're going to spend a decent amount of time here. So just to orient yourself, so this is kind of what we've been working with. So we've got a local repository. There's a master branch, which is the branch that I'm on right now. So head always refers to whatever branch, wherever point you're at right now. So I'm always head. So right now, this is effectively saying head is a sticky note that points to master, and master is a sticky note that's on this E137E9B commit. That's the hash, and that might be like the message first commit. Okay. So let's go ahead and just kind of walk through a couple of things. So what have we done so far? We've mostly just done a bunch of git commits. So we did a git commit, did a git commit, did a git commit. We made some changes. We're just kind of slowly walking around forward in time. And as we do, you can see that this master branch and the head where we are is advancing forward in time as we go. So the hashes don't really matter for our uses right now, but they're just advancing forward in time. Green is sort of tied to the commit that we're on right now, and these three are in the past. If you were to make a new, let's say you were to make an error, so that's what we check. So this, let's say in this commit here, since this is the question that's just came up, let's say this commit here, you checked in a password and you were like, oh, I did not mean to check in that password. I wasn't supposed to be keeping track of that in here. Then what you can do is you can git reset to another commit. So when you do a reset, depending on which options you use, it'll have slightly different behavior. There's a couple of different modes you can do, but one of them would just be to git reset. So go back as though I hadn't committed this. So I'm going to say go back to this commit here. So git reset to this previous commit, just one commit back. And so what that'll do is you can see it moves the head and the master pointers back to this commit as though this commit didn't happen. Now, what you'll notice is that this commit is not gone. It's merely dashed out. And that's because in the Git repository, that commit is still there. If you know the hash of that commit, you actually can still get back to it. So let's go back over to our terminal and show what that would look like. So here I did, what was my last commit? I added this bar file, but the file was empty. Man, I really didn't mean to commit that when it was empty. I wanted to commit that with some good code in it. So what I want to do, let's just say it also had the password, right? Keys to the kingdom sort of a thing. So what I could do is if I do my git log, I could say, okay, well, what was the previous commit? Okay, the previous commit was the C632 blah, blah, blah. Let's just copy that to the clipboard for a second. And we'll do git reset to that hash. And now when I do my git status, it's as though I had never made that commit. The working directory that I'm in doesn't change. So that file foo_bar.py is still there. It's just that I didn't actually commit it. It's like I never committed it. However, if we go back up here, with that commit where I did add it, added bar 0759 was its hash at the time. If I do a git show on that commit, it's still there. So it's still in the repository. Now, this is the repository that's on your local computer, right? Right now, we've only talked about things that are in your directory. So you haven't pushed this code anywhere yet. We'll get to that. And instead, this is sitting locally. So by default, if there's this becomes a dangling commit. That's what this is called. So this is a dangling commit. So there's nothing that's pointing to it. So here I have a master branch. It points to this commit, and then this commit points to that one points to that one. And so you can see that all these commits, these three commits, are all sort of still in use by Git. This one here, it's dangling. Git does periodic Git cleanups, garbage collections, and eventually this commit will get cleaned up. You can force that with a git cc -- aggressive. And then I don't do this as often. So there's a way you can force the garbage collection. This is one piece of it, and then there's a second piece that you have to do as well. I think it's like git prune or something. Remove, yeah, git prune. Okay, it is, because by default it has a certain time set, so I can say expire equals now, I think is how you do that. Okay, I will have to look back at how you expire that out right now. But the point is that this commit will still be there for a little while, and it's it can be a little tricky to get rid of it. Now, it's not on my local branch. The files aren't there. I could make a change, take the password out, and go back to doing whatever I was doing before and not actually commit that change. But you can get back to it. And actually, in the Hackfest talk that Jason mentioned before the workshop started, I talked a little bit about if you were a penetration tester and you ended up on a developer's computer, what you might expect to find, right? If you could find the Git directory, you might be able to find these passwords. And furthermore, if you don't clean these things up properly, or if you're a developer or a pen testing organization where there's a developer that didn't clean this up properly, then it might be possible to find things in the Git history of repositories. And this might be true on, say, github.com. If you were to search for, say, AWS token keys, you would find, I don't know, last I checked was several 100,000 examples of token keys on GitHub. See previous talk mentioned before. Because the naive way, right, sort of this is the correct way would be to revert the changes or reset the changes to back before you made the commits to before you committed the bad thing or the password or the whatever. The naive approach, what you might try and do would be like, oh, I just want to hide this away. Is if I had added that file, git add foo.bar, so we're sort of going back to where we were. Then if I committed that, added bar.py, and so there's my clean state. Maybe I would just try and do something like, oh, well, I'll just remove that file. So I'll just remove foo.bar, git status, and so it's showing me it's deleted, git commit -m, removed the secret file, git status. You can see it's not there anymore, but it is still there in the past. That file is still there, that commit's still there. So if you go back through the commit history, you can find some interesting things sometimes. Again, unless you clean them up correctly. So on a local machine, there's less impact if you do something like this. And now if I do a new commit, right, I go back to doing my work, it'll make a new commit. This one's still hanging out there, but I've gone off in a different direction. So now I can keep committing and life goes on as though that commit never happened. So that's sort of what we've been doing now. Is we've been doing commits, we've been moving forward in time, backward in time. Now let's hit on branching a little bit. So you can run clear. The other thing that I like about this editor here too, just real quick, is there's an undo. I wish this was an actual Git, but it's not. There's an undo and a redo command. Makes things quick pretty easy. So the next command we're going to introduce is git checkout. And we're going to give it the -b flags. This is saying, make me a new branch with some name. So I'm going to say new branch. Right. Okay, so now we see that there's head. Head is pointing to new branch, which is also saying up here, head is pointing to new branch. So I'm on the new branch. And there's also this other branch master over here that if I did git branch, it would show me the multiple branches that I have. So I see there's a master branch, there's a new branch, and that's the one that I have selected here. So now I could do git commit, I could do some work. Okay, now I could say, all right, well, I worked on that, but now I need to go back to master and I need to fix something up. So I could do git checkout master. I can jump back and forth with git checkout. So that's switching branches. So new branch, git checkout master. So that allows me to switch back and forth. And you can see here, head being the where you are is moving around. So if I do a git commit, now I'm making a new branch off in a different direction. And again, you could do this all at the terminal. It just allows you to or it just requires you to make a whole bunch of changes and sort of artificially create a bunch of changes in a repository. So now let's say, okay, I have this master branch and I want to pull in all the changes that were done over here on the new branch. All right, let's say Jason was doing some awesome work over here. He was adding some new feature that I wanted, and I'm like, oh yeah, I want that branch in my code. So if I come back to my command line, I could do git merge now. So this is saying take two branches, the branch that I'm on and some other branch that I'm going to reference. So in this case, I'm on the master branch at the moment. So I'm going to say git merge new branch. And what that'll do is that'll create a new commit with two different parent commits. So there's this commit up here where master was a minute ago, and also this new branch. So I've combined the code here from these two different commits. Now this works really well if Jason was changing one file and I was changing a different file during these two commits for Jason and these two for me. And this starts to get a little more interesting if the changes that I made are to the same file that Jason changed, and particularly if they're the same line. So what Git will do is it'll stop before it creates the commit. It'll sort of take the changes, put them together, go, hey, you both changed the same line, and I don't know how to figure out which one's the correct one. So it'll pause just before doing the commit and force you to resolve the change. So it'll give you a text where it'll say, okay, well, one of you said this and the other of you said that. Fix the code to be what you want it to be, and then go forward with the commit. And it will have the commands for that. So let's just go ahead and do that real quick. And for simplicity, I'm going to jump over here to Visual Studio Code so we can see a couple things. Okay, so I have my file here. Let's say that I was in here and I said, okay, on the master, let's say I'm going to do a git checkout -b fix spelling, right? So let's say I'm going to go through. I'm going to fix some things, and so I'm going to say, okay, check out a new branch. That branch, again, just to show it here, I'll use this GUI. You can see there's a master branch on this commit and a fixed spelling branch that's on this commit. And you can kind of tell that the fixed spelling is actually highlighted and circled in blue, and so that's the current branch that I'm on. Okay. Let's see if the demo's spirits are with me. So if I'm in this fixed spelling branch, and let's say for this, I want to say, okay, well, actually this is supposed to be, hello world, like that. So I could say git stat, git status, git diff. Okay, so all I did was change the spelling there. Git commit fixed the spelling. Okay, so that's that. Now, if I go back to my graph, I can see, all right, that fixed spelling branch has moved one commit ahead. So that's the same thing as what we saw here with this new branch. So we moved one commit forward, but master was still back here. And so now we're going to say, okay, well, let's say it wasn't me working on that branch. Let's say it was someone else working on that branch. So git checkout master, and let's say what I wanted to do is, I said, no, we're just not going to print hello world. And I'm going to say git status, git diff. Okay, I'm just removing that line. Yep, nothing changed. It's the lowercase one there. It wasn't the right thing. Git commit removed line. Git status. So now when we go back to our graph, we can see that fixed spelling went one way and master went a different way. And so this is simulating these two commits here. And now we're going to say, okay, that fixed spelling branch, I really like what's going on over there. So I'm on the master branch. Let me git merge fix spelling. And what I'll also say is a lot of newer operating systems by default will have tab completion. So give it a shot if you are in a terminal, and it might work. So like here, I just said git merge fix tab, and it will fill in the rest there. Okay. So git merge, it's trying to auto merge them. It's saying, there's a conflict in the content of this file. Automatic merge failed, fix the conflicts, and then commit the result. Now, before I fix them, what I want to do is show what git status looks like. So git status here is showing me that I have unmerged paths. If I wanted to, it tells me the command of how I would abort the merge. So if I said, all right, well, this is too complicated for me. I'm out of here. I'm not fighting Morpheus right now. Then you could git merge -- abort and go back to as though it didn't happen. So if I git merge abort, now I'm back on my master branch, and we're just hanging out separate, not doing anything right there. But let's say we do want to fight the dragons real quick. So git merge that other branch, git status, saying I have unmerged paths. It's telling me that both were modified. So this hostname.py file was modified in both of the branches, the one I was on and the one I was trying to merge in. And your editors will vary, but this is actually what the code looks like. So if I, just to make this even more clear, if I git diff this right now, Git has actually added into the file these left pointing arrows and head, a couple of equals, a bunch of equal signs, and then some right pointing arrows and fixed spelling. So this is saying on the left here, the arrows pointing to the left, is the head. This is the branch that I'm on when I did this. This equals is just a divider, and then this is what was happening on the fixed spelling branch. So on my side, I removed a line. On their side, this was the branch here. And there's a couple of ways that the command line you can do, accept ours, accept theirs. What I usually do whenever there's a commit is I just kind of search through my file for a bunch of equals until I find wherever in the file it was changed. Here, VS Code is actually doing a bunch of highlighting and giving me some context here where I can say, okay, accept my change, accept the incoming change from the other branch, which again are highlighted here. So it's saying incoming change versus current change. So I could just click one of those if I'm like, no, mine is the right way. We're going to remove that line. I can just click that. It'll clean up the files. It's not saved yet, so I can go ahead and save that. And then when I do my git diff again, it's going to show you something that basically the files didn't change. And git status, both were modified. So I'm going to add that file explicitly to mark it as, okay, I resolved the conflict there. All conflicts are fixed because I fixed all of them. And then I can git commit with no arguments to conclude the merge. Here it's opening up Nano, merge branch, fix spelling. That's just the default message it gives you is when you're merging branches. So I can, let's just sure, that's fine. So I merge that branch. If I do a git show, it's made a new hash. There's my description. If I come back into my graph, I can see, okay, there's a commit there. That's where I was a second ago. There's fixed spelling. Fixed spelling hasn't been touched. It's still hanging out there. It's still pointing to that commit. And master is now pointing to this commit, which has each of those two commits as its parent. Okay. So that's the status there. There's a number of other commands that you can do to do different things, which I'm not going to cover. Maybe there's a lead into a more advanced Git course going on here someday. But one that I just want to highlight just because there's a lot of questions about it is if I do, let's see, how do I want to do this? Do this. Git commit, make some commits, git checkout -b other git commit, git commit. So let's say I made this other branch, and then let's say I also did some work over here, git commit, right? So we're kind of basically in the same place we were right before we did the merge. One of the things you can do is instead of merging things, which created that merge commit and had the history from both sides, is you can do what's called a rebase. And this is another option that's like merge, but quite a bit more powerful and gives you actually some of the options that were asked about in Discord about cleaning up history. So if you said like, all right, well, all of these commits here on other, let's say I had a whole bunch of commits here. All right, maybe I don't want to show all the like broken pieces of the code before I got to this one as being the working copy. Git rebase gives you the ability to take all these things and squash them together. So you would take all these commits, combine the overall delta into one new commit and apply that to another branch. If you're just playing around in the GUI, This one, since it's not really a Git client, it's just using JavaScript to emulate a Git client. It doesn't work as it does on the command line. But to show just what a rebase looks like, if I'm on one branch, Git rebase says, okay, I know you did this commit, this branch other. It was these commits, and it went back to this commit that was shared by master. So master and other both share this ancestor. It's the first ancestor of these two branches. So what you can say is git rebase to some other branch. So I'm on other, so I'm going to rebase to master. And so what this is saying is, okay, I know that you made all these changes from this commit, but really you should have made them off of this commit over here. And so what that'll do is it'll move your head forward, it does a nice little animation. It'll take those 3 commits and it will replay those changes on some other point in the tree. Now again, here we said master, so it was pointing to the branch name that was this commit. That could have easily been some other branch over here. So I could say git checkout foo, so make a -b foo, make some new branch foo, and I could say, all right, git rebase onto, let's say, this commit back here. So replay all these commits since then onto that branch. I think this will work. So it'll go back over there, it'll take all the commits that are different, and it'll create new commits. It'll replay all of these commits onto that branch. This particular version doesn't have a lot of value, but other arbitrary branches, maybe you want to have this whole thing be off of this branch over here. Now, you can see by the fact that these are all different circles, is that these are all new commits. They aren't actually the same commit. They don't share the same history. And you have some options as you go. So there's a git rebase -I is the interactive mode. And I'd recommend if you're interested in doing this sort of thing that you read up on that command. But basically that's how you would do things like, okay, I'm going to take this commit and all of these commits, and I'm going to squash them all into one single commit. The other way you can do this is if you do a git reset. I don't think it's going to work in this emulator, but you could do something like this, where you're saying, okay, reset my git, the version of the Git repository that I'm at. Leave all the files alone, but just move the git commit back to here. And that will do effectively the same thing. So here, yeah, the emulator is assuming hard, which says throw away the working copy. Without the --hard that the emulator is doing, it says leave all the changes alone, but move the git pointer. And then you could actually just do a git commit, and you could make a new commit here that has all of this change all as one commit. That would be the way. That would be the non-rebase way to do that. So maybe that'll be a future Hackin Fest talk. Okay, so then what I want to do is kind of go on from that. So that's all working in one repository, right? I mentioned working with JSON, but really if I have my one repository here, I'm probably not actually sharing this with anyone. This is probably my copy on my computer. Jason wants a different copy on his computer. And there's a comment about ending up in Git hell if you aren't careful with this, and that's definitely true. I will point back to the XKCD comic that sort of alludes to that. What I will also say is that Git rebase is a very, very powerful tool with very, very sharp blades, and you can get yourself in a lot of trouble with it. So I would say when you're just starting off, don't even worry about it. Just work on your code, go forward in time. If you need to, use git reset to go backward in time as you need to. So I'm just going to jump back to the slides and just really quickly, I'll just throw it up in this view. Talk about remote. So far we've been just one developer working on their local repository. And if you actually want to start contributing to some open source project or sharing your code with someone, right? Maybe it's an internal Git server, or it could actually be just a file system based Git server. You can actually just have a directory that is your Git server. You can actually have your code and get the code from one place and check out a copy locally. And then, so let's say I could have a copy here, Jason could have a copy here, and Stephanie could have a copy over here. And we could each be working back and forth with the code. And so this visualization, there's a couple of different pre-canned examples up here. So I'm going to move over to the free Explorer with remote, which will reset things here. And this is just kind of another way, again, to show how this is all working. And so things have changed a little bit since we were last here. So now there's an origin. By default, Git uses, like it uses master for the default branch, it uses, by convention, origin for the default server. So a lot of times if you go to GitHub and you clone a repository, which we'll talk about shortly, then the remote is called origin. And so what's added is, so here's the server copy, if you want to think of it that way. There could be multiple servers. This server is not unique in any particular way. And then this is my local repository on my local computer. There's one new branch that showed up. So there's origin/master is another branch that's in this stack of branches or stack of sticky notes that are applied to this one commit. And origin master is the last place I knew where the server was. So we're going to introduce a couple of new commands here. One way you could end up in this state is if you went to GitHub, let's say you go to, just for giggles, you go to my blog and you click this green button and you'll get a URL and you can copy that. And from a terminal, you could do something like git clone some URL from GitHub or GitLab or wherever else you wanted to. And you would end up with a directory that looks like this. So I've got this repository, there's some code in it, and it looks like this code here. So data includes pages, data includes pages. This is the code that came off the server. If I do a git status, I'm on main. Like I said, I switch this to use the main instead of master. And now I get one extra bit of information. Your branch is up to date with origin master. And that's pretty much what's being shown here. So I've got a master branch in this case. There's an origin master, or on the origin remote, there is a master branch. And last I knew, it was pointing to this commit, which over here, the server is showing you that, yep, master is pointing to that commit. Okay, so let's say now I want to do some work. So I've cloned the repository down. I do my work, right? So this is now, we've gone one step further from, I just have this project, this really cool script idea that I'm working on, and I want to keep track of it. So now we move one step further from that to, I have this really cool script. I want to keep track of it, but I'm worried that I want it available on more than just my computer, or I want it more than just on my one computer. I want to be able to develop it on two different computers, right? Maybe my Windows PC here and the Kali Linux OS that I've got in a VM, for instance. I want to be able to push back and forth. So here on my local computer, let's say my desktop, I was doing some commits, I was doing some work. And so the master branch, this is my local master branch, this yellow branch here, label here, sticky note, if you will, is pointing to this new commit here. The server knows nothing about that yet. And as far as I know, the server is still on origin master. It's still back pointing at that commit over there. So after I do a series of commits, what I'll do next, if I'm assuming that I've started from git cloning something that's on some code hosting tool, is I can push the commits that I have. So what this will do with no other arguments is take the branch that I'm on and push it to the server. So I'm going to say git push. And what that'll do is it'll take the new commits that were on my local desktop and push them up to the server here. And it will update all the branches on the server side, so the master branch on the server. And because I just did a push, I just had that conversation with the server, I know that origin master is at that point because I just put it at that point. And so this is how you would do it. And so I could do git command prompt git commit, git push. So now I'm doing basically the same thing I was doing before. I'm just doing some local development work. I'm making some changes. And when I'm ready, I push it to the server. If I was to make a new branch, let's say Wild West Hackin Fest. Then I could push that to the and then I did some work on it first. That moves along, and then I could push that branch to the server. So the first time you push a new branch, you'll use the -u or the --set origin, but I usually use just -u origin for what remote I'm pushing it to, and then the name of the branch that I want to create, or the name of the branch that I want to push. So in this case, Wild West Hackin Fest. So I've got this branch here, and I've pushed it ahead there. So here's where the GUI is going to get a little hairy on me. So I've got a master branch on the server. I've got a master branch locally. I've got a Wild West Hackin Fest branch on the server. I've got a Wild West Hackin Fest branch locally. They point to the same commit for both of those. The other thing is you can see the server has a head commit, and that's the default branch. So if I was to clone it, that's the branch that I would get. This other branch is still on the server. I could check it out if I wanted to, but I don't, it's not the one that I start on. So if I go back to the master branch, make some changes, those are again just happening locally, and maybe they never ever get pushed to the server. So that's just showing that example of, I'm doing some work, I'm pushing it to the server, and I'm just keeping track of it. If I was on another system, I would do, and let's say like yesterday, I cloned a copy and Jason cloned a copy, and then last night, Jason pushed a copy to the server. In order for me to get the version that he pushed, I would do a git pull. So git pull says, pull down all the changes from the remote, and also update the branch that I'm on. So I'm on the master branch right now. If the master branch changed on the server, then go ahead and update my local state to be whatever the master branch on the server is at. In this case, I'm actually ahead of the server. I made these two new commits up here. So it's saying it's fetch 0 commits on each of the branches, and I'm already up to date. Now, the reason it says fetched is because there's actually two things going on here. One is actually a git fetch, and the other is a git merge. So it's pulling down the commits from the server, just pulling down the references to them, but not actually updating anything. And then the second is actually updating them. So git pull does both of those things. Usually, for most cases, you'll want to just use git pull, but there are actually two commands there. And so to show that a little bit better, there's this upstream changes template here. And so here you can see in my local copy, I've got this feature branch, and on the server, these three commits are also on the server, these three here. But feature up here, that's the feature that Jason updated. I haven't pulled that one down. I haven't seen that change yet. So I could do a git pull, so my head branch, the branch I'm on is feature. So I could just do a git pull, and it will pull down that commit. That's why you saw it fetched as a dash line briefly. So let me undo that and redo that. Oops, undo git pull. So it creates a commit and then updates it. So it does a fetch and then a merge to update the things. Alternatively, I could actually do that in 2 steps. So I could do a git fetch just to get the change. So here the sticky note, the branch I have locally for origin feature is updated with the server, the state of the server, but my local state hasn't actually been changed yet. And so what this means is feature is actually, git fetch rather, is not impacting your state, so it's safe to run anytime you want. So I'll run git fetch a lot if I'm working on a fairly active repo. So I always get that local state, or a local copy of the remote state, but without actually impacting anything. And then if I say, okay, well, I see that there's that new commit, and I didn't do a pull. I could just do a git pull if I wanted to, but I could also do a git merge origin feature to manually update my branch to that commit there. Then I could do some more work, git commit, git push, to push those commits up to the server. And so that's a lot of what you'll need for interacting with both a repository you have locally, something that like never goes out to a server ever, as well as what you can do if you do want to, make an account on GitHub or GitLab, or Git was a new one that I hadn't heard of that someone mentioned in Discord. And just interact with yourself. You have just a repository, you're pushing and pulling, you're not really interacting with any other people. Or if you're actually interacting with an open source project or some other project, this is a lot of the mechanics of what you'll use, right? Functionally speaking, you're fetching and pulling changes off the server that two different developers are both pointing to, right? This graph here, here's the server. I'm pushing and pulling changes back and forth. Another developer is pushing and pulling back and forth. Another person pushing and pulling back and forth. And this is a way to keep in sync with each other. You actually could have multiple remotes. I'm not going to really cover it, but you could have multiple remotes. So you could have one remote that says where you're pushing to, let's say, GitHub, but then theoretically, at least, you could have your developer push and pull directly from another developer. It's not done very often. More commonly, where you'll see this is you have an open source project that you don't have the ability to change, and you have a fork of that repository that you are able to change. So it's sort of your local server, your server copy, your personal server copy of it. And you can push and pull to that, but you also want to be able to pull the changes from the upstream project as well. And so there's mechanisms in Git for doing that as well. And I have a couple of links here for different tutorials. Some of these are actually branching sort of other JavaScript-based GUI web browser tutorials. You can also find the slides for this talk here. Since the splitting this course in half didn't end up working out quite as well as I had hoped, what I want to do then is move on to the last piece, which is basically priming you all to go out and do this in the wild. And it kind of goes to, it's like, is that Ian Mayer's question? And kind of JD's question as well, apparently. How do I interact with an open source project? So that's what I want to cover lightning fast in the last 10 minutes. So there's a number of different code hosting platforms out there: GitLab, GitHub, SourceForge is making a comeback, although that was more Subversion based for a long time. Bitbucket's out there. I put a little slide here about setting up SSH keys. So I personally recommend using an SSH key for doing your Git interactions, so you don't have to type your username and password every time. Documentation varies, but there's the link of where you would set that up in GitHub. So I want to just kind of jump ahead and show some examples. So what I did last night was, and I'm gonna shrink this to show not the spoiled version, is I jumped around from a couple of things that showed up in this conference to show some real examples of how we would do this. So I'm going to do these as though I had, well, in this case I did. I literally came across this project and I said, hey, here's a cool open source project, ADHD. Hey, love that. I'm reading through their documentation. I've done this with blog posts, where a lot of blog posts, mine included, the site for this workshop, which I'll add more content to later, are Git repositories. And as you're reading through, you might find, hey, there's a typo, or something's worded right. Or in this case, what I found as I was just poking around is, hey, there's a link, adhdproject.github.io, that isn't actually a link. It's just the text in the project. So I'm like, all right, well, I want to be a good citizen. I'm going back to my second slide there. I want to leave things better than I found them. So I want to just go in and fix this, just this link. That's all I'm going to do. I'm not making any changes. I'm not really contributing to ADHD Labs. I just want to fix this link because, it'll take me 5 minutes, and that would be being a good person. So if I click on this link here, this is what the actual website looks like. This is where I found the link that wasn't rendering. And the second link down here is actually the GitHub page, GitHub repository for this code. So under the ADHD project organization, there's this ADHD project.github.io repository. Inside of that, there's a Wild West Hackin Fest /2020/Deadwood/intro directory structure with this file, intro, blah, 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 .markdown. And if I scroll down here, I can find that, yep, there's the thing that could be a link. It's not a link, could be a link. Now, I don't own this project. This is not my project. I can't just make a change to this file. And depending on which GUI tool you're using, you could do this from the command line, you could do this from the GUI. For the sake of time, I'm going to show the GUI version of it for GitHub, but GitLab, Bitbucket, they all have very similar interfaces. So once you're signed into GitHub, if you actually click this, if you go to a file, then in the top right of that file, you'll see this edit the file in your fork of this project. So this is where I was talking about there can be multiple remotes. So in this case, there's the real project that I don't control, but I can make a fork of it and I can have full permission to change that copy. So I'm gonna click that pencil button. It made a fork for me. I may actually have had that already. You're making changes in a project you don't have write access to. Submitting a change will write it to a new branch in your fork, Ian Lee 1521/ADHD project, blah, 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 so you can send a pull request. So this is going to the question in Discord. So in this case, GitHub, and again, all the other tools have their own little hosting tools here. And effectively what's happening here is there's a markdown file. This is a URL, but the GitHub markdown engine is not rendering it as a URL. So what I could do is I could just change that. I could say, okay, like that, HTTPS / whatever this here, like so. So I could actually just right here in the browser without ever needing a terminal, add the markdown syntax for that link. Then this is showing an edit tab. I could also go preview it. If I wanted to, it'll show me what the change is. It'll show me that, hey, that's a clickable link. I could test it. Yep, that takes me to where I wanted it to take me. So I can go back over here to the edit. Then I could scroll down, and now I can say propose those changes. So it's giving me kind of an idea. This isn't the actual text, but it's giving me an idea of what I might type. This would be the commit message here. The reason it's in 2 blocks is that short versus long description that I was talking about. So this one's expected to be short. So if I actually make this too longer, it'll pop up a little help text. Great commit summaries are fewer than 50 characters. So I can say, okay, well, add hyperlink for URL. Intro to Git workshop at Wildhouse Hackin Fest 2020 says hello. Right. And then I have a couple of different email addresses associated with my GitHub account. I could choose which one I actually wanted to use, and then I could propose the changes. So in this case, it'll actually make the commit and start me on a pull request making the change for it. So here it's showing me the change, just sort of previewing the change, saying the base repository, the upstream repository is ADHD project. I'm on my copy of that project. It made a new branch, patch 1, just filling in a name for itself. And I could say, just create pull request right here. It takes that commit message and turns it into the details of the commit message, or it's the details of the pull request, so the summary and the details. I could add some more things if I wanted to. I could preview it if I'm using Markdown. You can do a whole bunch of other things in GitHub. And then you can say, create pull request. And so now I've made this change on a new branch, patch 1, on my copy of this project. And I have created a pull request here. This is a real pull request to the project where I've changed this one file. That's how the file got changed to add that URL. We could have a conversation. If there's someone who does have write access to this project, they could come in and say like, no, I'm not doing that. GitHub will, and all the other hosting tools will give you some helpful UI about if there's conflicts or not. And generally the convention is you, the submitter of a patch, are the one who's supposed to resolve any conflicts, typically. And eventually someone might come in and say, hey, that looks great, merge that pull request, and theoretically it could happen right here while I'm seeing it. Alternatively, I could have come to the project here, fork to the project, so click on the fork button up here, fork it into a particular account. Here it's showing me I already have a fork. So I can go to my copy of it. I could clone that down. I could, here, we'll just do this. So I'll clone that down to, already did. I could check out a new branch, patch test. I could look at what remotes I'm looking at. So in this case, get remote-v will show me the list of remotes. Here you can see I actually pulled the upstream version. Get remote has a way to fix that. So I can say get remote set URL for the origin remote to be not the upstream, but instead to be my fork of it there. So get remote-v will show me, hey, it's using my copy now. Now I could actually push that thing. Get push track onto the origin patch test. And it's showing me there's a new branch here. Some servers will actually give you some help text back. So here there's a link. I could actually go to this link. Let's see. And it's that same previewing message. In this case, it was a new patch. I didn't actually make any changes, so it's showing me there's nothing changed. But if there was changes, I could go through and make a pull request this way as well. There you can see the one pull request. And so what I did, so that was just one example, right? That took me, what, 8 minutes while talking through all the details of the change to make that one change, right? And that project could now be just a little bit better, in my opinion. Maybe they disagree with me and say, hey, thanks for the submission, but we don't want to have that URL be a link. That's the prerogative of the project owners. Now, maybe I decide, you know what, hey, ADHD, I could do that better. I'm going to take my fork and I'm going to go off and develop that all on my own. And assuming you're staying within the open source licensing, that's something you're totally able to do. I went through and I found a couple of other examples that, if we had enough time, maybe if you want to follow this up after class on your own, right? These could be some of the first pull requests you do. So I was looking at Active Countermeasures Rita project, and I was reading through the documentation. I've been spending 2020 getting more involved with using Docker. So I was like, oh, let me look at the Docker documentation. And then I was like, oh, okay. So I'm reading through the documentation, and I noticed if you want to use a different version of Rita than the default latest, you can do so with the Rita version variable. But then I looked at the sample there, and it's exporting version, not Rita version. So then I went and looked at the code, and ultimately I found out that version is correct and Rita version is wrong. So one pull request that you could do would be to go to this page and update that to be version instead of Rita version, and that would be a fix to their documentation, be a little bit better for the next person who found that project. In the case of like this ADHD site, when we went to it, there wasn't actually any way to get this. You kind of had to know. In this case, it made it a little easier because it's adhdproject.github.io. That's sort of a tip-off that it's a GitHub Pages site. So you kind of have to know that that's a GitHub repo and go hunt it down. It took me a couple minutes to do that. What some projects will do is they'll actually embed edit this page link. And so you can just click that page, or click that link rather, and it'll take you right to GitHub, to the appropriate fork this repository, and then you could go through the same editing that we showed for the first example. I mentioned GitHub Pages. I know I'm basically right at the top of the hour, so I don't want to go too much further, but GitHub Pages is another site, another thing you could sort of get some more exposure to. GitHub Pages or GitLab Pages or Bitbucket Pages are all Git repositories using a Markdown generator. You can write Markdown and it will get rendered into HTML. So my website is actually a GitHub Pages site that becomes, my site there. The ADHD page here, same thing. It actually turns out all of the Docker documentation is also a GitHub Pages site. They're just using docker.com for their domain, or docs.docker.com, kind of like how I'm actually using my domain name instead of enly1521.github.io. Found a couple of other tools, just with a couple of ideas of things that you might be willing to do, right? So if you're reading through something, hey, maybe some documentation updates. Doesn't take a deep developer background to do that. I was looking at Mimikatz and I saw in the README they mentioned the license, but they actually don't have a license file. Maybe just try and contribute that. For Metasploit, adding a new exploit if you're so inclined. Marcello's CrapMac exec, you could consider adding some CI testing. There's also all these awesome lists for different lists of skills or links to other information that you can go through to really learn about a particular subject area. And maybe you decide, hey, I have another example I want to add to that project. And so the last thing is kind of what I want to leave you off with is just what we started with. So I strongly encourage you to just start any code or documentation or notes that you're doing with a Git init to make the directory, and then just start using Git to track that, right? Markdown's an incredibly easy language to write. Even if you never intend to share it with anyone, it can be a great way to practice your skills. And you really don't have to be, the best developer ever to make a meaningful impact on a project. A lot of times the documentation updates are the most important because you as the person reading something saying, hey, I've never looked at this code before, you have a different viewpoint than the person that wrote it, who implicitly knows what that code's supposed to do and really tends to gloss over some of the details. So I'll hang out in Discord for a while, going back to the XKCD comic from earlier, right? If you ever want to reach out to me on Twitter, Discord, et cetera, and ask your Git questions, please feel free to. And just go forth and leave things a little bit better.